Okay. Chapter 4 review. It's my intention to get through as much of this as we can today, possibly the whole thing, hopefully the whole thing. We should be able to get through the whole thing. So the better notes that you can take today will better prepare you for the test tomorrow. Okay? You'll have the test earlier in the morning tomorrow because we've got class right after chapel tomorrow. So take good notes. You know how it works. If you can use your notes, you can use your book for the test. So whatever it is that you have that you brought with you to class, granted you remembered to bring it, then we'll be all set. Okay? So we'll go through these. Please pay attention so that you can ask any questions on any sections. And if you can get it cleared up today, then it won't be an issue tomorrow. Choose a benchmark. Number 1, for each measurement, 0, half, or 1. 3/8. Remember how this works real quick. So when I think of the denominator 8, it helps me determine what it's closest to. If it's closest to 0, the numerator will be closer to 0/8, right? 0. If it's closer to 1 whole, it'll be closer to 8. Now half, it's easier when the denominator is even because you know that half is represented by 4/8 for that fraction with a denominator of 8. So the 3/8 is the closest to 0/8, 4/8, or 8/8. Has to be 4/8. Therefore, we would estimate or round that to be half. Okay? Number 2, 13/29. Now the 0 and the 1 whole are easy. The half is where it sometimes gets a little bit tricky, especially when you have an odd number for your denominator. What is half of 29? Well, if you're not sure what half of 29 is, then think of like the denominator before it, the denominator after it. What's the denominator of, or half of 28? 14. Half of 30? 15. In between 14 and 15? 14.5. Somewhere in that neighborhood is exactly half. Well, it is exactly half. So 13, is it closer to 0, 14 and a half, or 29? Trinity. So we would again round that to be half because it's closer to 14 and a half than anything else. All right. Number 3, 14/17. So are we looking at closer to 0/17, 8.5 17ths, or 17/17? Closer to 17/17, which is going to get us 1. And then 1/19. Definitely closest to 0. Okay? Any questions on those 4 using the benchmarks? 5 through 8, I saw a blank on more than a couple of tests. Basically, what we're going to do is we're going to take the same principles that we used in 1 through 4 and apply them for 5 and 6 because those are regular fractions, and we're just going to either add or subtract them. So for number 5, we have 7/13 plus an 8/9. Well, if 7/13 was one of the fractions that we would have had in the top 4 in the first 4 problems, would we say that this is closest to 0, half, or 1? Half. And what about the 8/9? So do we say that's closest to 0, half, or 1? Sydney, 1? So now we just add what we came up with, and half plus 1 is 1 and a half. Number 6, 13/17 minus a 7/16. Well, we didn't have a 13/17 up top, but we did have a 14/17. What do we do with the 14/17 up top? Number 3, we put it to 1. So I would still say 1 is a pretty good estimate there. And 7/16, half. Now 1 whole minus half half. The rules change a little bit for 7 and 8. Why? Why do the rules change ever so slightly for 7 and 8? Raven, they're mixed numbers. So I no longer use the benchmarks 0, half, or 1. I simply round to the nearest whole. Okay? So whenever we do our rounding, we always said that, like, if the digit behind it was 5 or bigger, we'd round up. We're not using a 5. What fraction would best represent, like, a 5? Half. So if our fraction represents a value that's half or larger, we round up. How does 1/3 fit into that scenario? Is 1/3 half or larger? So what are we going to round 5 and 1/3 to? How about 7/8? Is 7/8 half or larger, Trinity? Larger, so I'm going to round this to what? 7. 5 plus 7 is 12. And then number 8, 6 2/3 minus 3 19 over 31. Okay. 6 2/3, it's pretty easy. That would round to what? 7. Right? 2/3 is greater than half. What's half of 3? 1.5. Isn't that 2 bigger than 1.5? Okay, just by a little bit, but it's still big enough to change it. Now here, 31 is 19 over 31 half or larger? What's half of 31? Granted, what's half of 30 and half of 32? What's half of 30? 15. Half of 32? 16. So technically half is 15.5. How does the 19 fit with that? Definitely larger, so we round that to equals 3. Yes, sir.
So, like, wouldn't it be closer to half than like the whole numbers? Is like,
If, Joe, if this were a standalone fraction and there was no whole number to go with it, then you are absolutely correct. We would round that to half. However, it's not. The fact of the matter is, this is a mixed number. And because it's a mixed number, we round to the nearest whole number. That's why. Okay? So you have to kind of adjust your thinking just a little bit when working with mixed numbers. You still think of them in terms of half, but half is going to be what, rounds it up. Okay? Numbers 9 through 16. Number 9, 1/8 plus 3/8 equals how many eighths? 4/8, which equals what in simplest form? Half. Good. So number 9 is half. 10, 17 25th plus 6 25th equals 23 25th. That's in simplest form. Number 11, 7/8 minus 5/8, 2/8, which equal 1/4. Very good. Is it wrong if you don't have 1/4? Yes, you have to simplify, yes, and it's even in the directions. The next one, 61 over 32 minus 47 over 32. 61 minus 47. Number 12. $14. We're gonna subtract these top numbers, Maddie. So 61 minus 47 is going to give us the 14. We do not subtract the bottom ones if they're the same. Okay? Is that in simplest form? Cut them in half. 7 over 16. Any questions on when they have like denominators? When they have like ones, Trinity? What did you have? So what did you do differently? That's what we did. You did what we did. So we're good. Okay? If you got here, Trinity, that means you must have done something that you should have done. Okay? Now, 13 through 16, we do not have common denominators, so we have to get there. So the crash course on that, I've got a 5 and a 10. Which one am I going to focus on to make sure I get the same denominator, the larger one or the smaller one? So if I use the larger one, I'll ask myself, does that larger one also work for the smaller one? Yeah, it's also a multiple. So 5 times 2 is 10. 3 times 2 is 6. That stays the same. Add them up. 9/10. The next one, 5/8 plus 2/3. Between an 8 and a 3, 8 doesn't work for 3. What's the next multiple of 8? 16. Does 16 work for 3? No. How about 24? So 8 times 3, 5 times 3 is 15. Times 8, 8 times 2 is 16. 15 plus 16. Improper, I have to fix it once. Good so far. 1 and 7, 24. 15. 5/8 minus 7 12. Use the 12. No, not for 8. Next multiple. So 8 times 3 is 15. Times 2, 15 minus 14. And then 16 25th minus 1/3. 25 and 3. 25 doesn't work for 3. That's 50. The 75. We got to use 75. 25 times 3. 3 times 16, 48. 3 times 25. 1 times 25, 25. 3, 23 over 75. Process doesn't change. Numbers are just a little bit larger than what you're used to. Anything on 9 through 16? Maybe got them all right on 9 through 16. Miss one? Must not have been a major issue. 17, 8 and 2/3 plus 5 and 3/12. Okay. Now, one thing I want you to just be aware of, if you see within any of your problems when you're adding, subtracting, multiplying, dividing, whatever it is with your fractions, you see that something can be simplified. Is it okay to simplify it now? Yes. What can be simplified? 3/12 to what? How about 1/4? Okay. If we're going to do it, make sure we do it the right way. Otherwise, you really mess stuff up, right? So then between the 4 and the 3, use the 4. 4, 8, 12. Which is probably what you would have had anyway, but that's all right. Times 4, 8, times 3, 3. 8 plus 3, 11. 8 plus 5, 13, 11, 12. Sometimes you find a shortcut by simplifying. Sometimes you end up going right back where you started. but you never know unless you, good. 6 5/8 minus 2 1/6. Between the 8 and the 6, 24. Times 3 is 15. Times 4 is 4. 15 minus 4. 6 minus 2, 4. Not a whole lot of tricks so far, right? Didn't see a whole lot of tricks yet? Yet. I got both of those right. 19. We said that we were going to add for 19. 1 3/8. 1 3/5. Between an 8 and a 5, 40. 8 times 5, 5 times 3. 5 times 8, 8 times 3. So 9, 39 over 40, and 2. $20. Basketball hoop 10. And we said we were going to subtract. Here it might get a little bit interesting. We'll use 24. There's my 1. There's my 22. Now, here, what is the problem? Well, I can take 1 from 22. I can't take 22 from 1. So I need more 24ths, right? How many 24ths did I take if I took 1 whole? Plus, how many are there? So I should have 25 minus 22 is 3. 9 minus 5 is 4. Simplified, 4 and 1/8. Okay, now that's the front side. The whole front side. On the back? Don't feed into it. All right, so we're going to take this first section, Maddie, 21 to 26. Is that what your question is? Good. All right. And there were a handful of yours where I saw it completely blank. Well, you got a couple arrows there. Not completely blank. Elbow. Okay. Now, if this part is truly difficult for you, if this part is truly something that's caused you problems, then this is definitely the part where you don't want to be not paying attention or distracted by something else. Now, we tried to spell out every single one of these yesterday before we got you started. So let's go back and review. I need to find out what x is. In order to do that, I need to do the opposite of what's currently happening to it on that side. And when I say side, I mean side of that equals sign. Okay? What is currently happening here on this side? We are subtracting 3 and 2/3. So I have to do the opposite of subtracting 3 and 2/3, which is to do what? Add. Add 3 and 2/3. Okay? When I add a 3 and 2/3 to a negative 3 and 2/3, what do I get? Which means now this has gone and I'm left with just x on that side. That's why I do the opposite. All right, so now we can just get to doing what we were doing on the front side. With an 8 and a 3, get them to 24ths. times 3 is 9, times 8 is 16. 9 plus 16, 2 plus 3 is 5. Can we simplify? Can we get this any more simple than it already is? Trinity? So how many times does 25 or 24 go into 25? One more time, so that'll give us 6. How many are left? 6 and 1, 24. Now there is a way you can check it without necessarily having to do the whole problem over again. Because you learn that skill where? Numbers 7 and 8. Numbers 7 and 8 kind of taught you how to estimate a little bit, to round, then estimate real quickly. So 6 and 1/24 for x would round to 6, right? 3 and 2/3 rounds up to 4. 6 minus 4, does it give you somewhere in the neighborhood of 2? Yeah. Okay, so if you kind of just go back mentally and just fill it in, check it, you don't have to go back and do the entire problem over again. But if you did something crazy like subtracted 3, it ended up with like a -1, or it did something completely off, you plug it into the original problem and you're going to find out right away that something is wrong. And then you have to go back and fix it. You can't just, well, got that one wrong. Go to the next one. No. So 22 then, since we did 21, 22 is lined up the same way. X minus 1 2/5 is equal to 3 and 7/15. So the opposite of subtracting 1 2/5 is going to be add 1 2/5. We'll use 15 times 3 is 6. Add 7 and 6. 13/15. 4 and 13/15. 4 minus 1, does it give us somewhere around 3? Can we plug it back in? Sure. Now tomorrow I'm going to bring you back to this part. I'm going to bring you back to 139. Okay, bring it back to 1. It's still 139. And of the 16 of you that are in here, I can tell that like 3 of you are paying attention. So I'm just saying that when tomorrow comes around, you say, oh, that part's too hard, I don't know what I'm doing. Here, let's... Now, if you notice a pattern for numbers 21 through 23, they're all having you do the same thing. The opposite operation in all of those first 3, you're adding. So we're gonna take the opposite. We're gonna add 4 and 3/4. Use 4, 5/4. 6 and 5/4 becomes what? 7 and 1/4. Does it make sense? 7 minus 4, almost 5. Does it give us somewhere in the ballpark of 2? Absolutely. Okay. Now, most of you are a lot more comfortable adding numbers than you are subtracting, which makes 24 through 26 just a little bit more challenging. Not necessarily difficult, but just a little bit more challenging. So as we take a look at what they have laid out for us for number 24, there's no reason that when you see this tomorrow that it should cause any confusion. It looks a little bit different because you're not starting off with x. Like we did here, x minus 4 and 3/4. Here, 4 and 4/5 plus x. Okay? It doesn't necessarily matter for adding what order they come in. So if we look at what we've got here on this side, the way we get rid of a positive is to do what? Negative, which what operation would you think of when you think of negative?
Subtract.
Subtract. Just like the opposite of subtraction would be addition, like we did for the first three. In order to get this x by itself, I need to get rid of this positive 4 and 4/5. Again, how would I get rid of it? The opposite of the positive would be to subtract it. We'll use 15. And we've got 12. What has to be done? So if it's not enough that they have you using this in equation form, now they're going to ask you to rename and to make sure that you have enough 15ths to do the subtraction. I don't right now, so I need to borrow how many 15ths? 15 plus the 11 that are there. 26 minus 12. And 5 minus 4. So 1 and 14, 15. So again, plug it in. 5 plus about 2 should give you somewhere around 7, right? When you estimate, when you round. Plug it back in. 25 is structured the same way. 1 and 7/8 plus x is equal to a 6 and 19/24. Let's subtract 1 and 7/8 from both sides. Again, I run into the same problem. So I need to borrow. This time I'm going to borrow 24/24. So 24 plus 20, if we say that's 20, is 44, but it's not quite. So we'll call it 43. 22 over 24. 4 and 22/24. Is it done? No, I got to simplify. Four and 11/12. Pardon me? That was 25. 4 and 11/12. And 26. X plus 1 and 9/10 is equal to a 5 and 13/15. So here, let's subtract 1 and 9/10, and between a 15 and a 10, 30. 26, and 27, of course, it's got to be one bigger. So I just borrowed how many 30ths? 30. 56 minus 27. And 3. 3 and 29/30. Anyone get all 6 of them right? Good work. If you know your opposites and you know how to add and subtract with mixed numbers, you're going to be fine. That's all it is. Don't make it harder than it is. Did we skip 27/28? All right. Another brain-busting section appeared to be 29-31. Susie's birthday party. How many minutes do they plan to swim? All right, so they start lunch at 12:30. It goes to 1:45. 1:45 to 3:20 opening gifts. So let's set up 3:20. They're both PM times, right? They're both PM. So I'll set up my later time, and I'll subtract the earlier time. 3:20 minus 1:45. So I don't have enough minutes below to take away from 20. I need more minutes. So I take an hour's worth of minutes, which happens to be 60. So add 60 to the 20 that are there. Make it 80. So I'm left with 1 hour 35 minutes. Is that the answer? No. What is the question, Cal? What's the question?
How many minutes do it?
All right, so if it's good. So if it's 95 minutes is what we're looking for. Because 1 hour is 60 minutes plus the 35 gives us 90.
Okay, if it was like, if we didn't have to do all the minutes, how many hours would it be? Wouldn't it be like 2 hours, 5 minutes?
To swim? No, it's right here, 1 hour 35 minutes. How long will the games last? So we go from 5:35 to 7:05? So it presents me with the same problem that I had before. Yeah, I will subtract. Very good. But I don't have enough in the minutes column, so I have to add an hour's worth. Hour and 30 minutes.
Wait.
For what 2 minutes? No, not 30. Does 30 ask how many minutes? Does not ask. Oh, you don't even have a test in front of you. If dinner ends at 8:12, how long will the party be? So 8:12 is my later time. It's PM. What time did it start? 12 what? Okay, so kind of a problem, but we do have an option of rewriting the 8:12 to mean the same time. Military time. 8:12 really means 20, Keith. Yeah, good. 2012. Now, again, presented with the same problem. I don't have enough in the minute column. So now I got to make that 19, add 60 to the 12, 72. So 42, 7 hours and 42 minutes. No thank you. Okay? All right, 32. Cal is building a fence. Calvin, not Calvin. The fence will enclose a 100 square foot area, 10 by 10. So remember, we said this question's coming directly from that draw diagram section. So if you didn't draw a diagram, so let's make a, check this out. Where is it? Whoop. Okay. So let's say 10 feet by 10 feet. Okay. All right. So if Calvin can put fence posts 2 feet apart, how many fence posts will he use? Okay. So 2 feet apart. Now, if it's 10 by 10, I can separate into how many sections? How many 2 feet sections can I separate into? 5. How many lines do I draw to get 5 sections? 4. Good. So 1, 2, 3, 4. And if I draw 4 vertically, all right. Okay, so each of these represent a 2-foot area. Okay? We're going to put a fence post on each where it marks off 2 feet. So those are all fence posts. How many fence posts will Calvin use? 20? What is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 posts.